One of the most important skills with graphs you can learn is how to spot patterns in coordinates. Now, good mathematicians are basically just good pattern spotters, and with graphs it's really important to appreciate that. So, let's consider this. I want you to write down two coordinates where the y part is one more than the x part. That should be pretty simple, considering that each coordinate has an x value and a y. So, write down any two out of infinity, where this number here is one more than that. So you should come up with some numbers like 3 and 4. As long as it's one more, we're all good. Now, to make things a bit harder, I'm going to use a negative number, and one more than that, if we go up the number line 1, you get to -6. Now, this is a sentence, but what I'm going to ask us to do now is describe it in maybe a different way. So here we could say that the y is one more than the x, but what if we started with the x is? You should be able to see that it's one less in both cases. So we say the x coordinate is always one less than the y, or like the question said, the y is always one more than the x. Now, we need to try and turn this into more mathematical language, because good mathematicians, we don't write sentences. So instead of saying the x coordinate, we could simply say x is always, well, we have a symbol for that, equals, and one less than the y means we're having to take one away from the y, so it's the y, take away 1. And this is the equation of the line that these 2 points go through. Now the other way, the y coordinate is always one more than the x, so this time we're going to have to add 1 on to this value, so x plus 1. So these are both the same thing. They've just been rearranged technically, but they both describe the patterns that occur between these two. So let's have a look at another one. So I'd suggest you pause the video now, have a look for the pattern yourself, and then hit play when you're ready. So hopefully you've seen that there's a difference of 3. So let's try and write it. So you should see that the x coordinate here is always 3 less. The blue ones are 3 less than the pinky purpley ones. Or if you start with the y's, you should be able to see that they're 3 more each time than the x. So the x is always 3 less, so that's y take away 3, or the y coordinate is always equals 3 more, so we have to add 3 onto the x. So this time these equations are on the line x equals y minus 3 or y equals x plus 3. These are the same thing, just in a different way around. Again, pause it, see if you can do it for this one. So you should be able to see there's 7 less if you go from the x, or 7 more to get to the y. So the x coordinate is always 7 more than the y, or the y coordinate is always 7 less than the x. So let's put this in a sentence. The x equals 7 more, so it's y plus 7, or the y equals 7 less, so this time we're taking away 7. Pretty simple. Until you get to this one. You should get a little bit more stuck, but you should, if you keep looking at it, see it. And I've given you 3 to help you spot the pattern, especially with the negatives. So this time it's not adding, because it's adding 2, but then we're adding 4. So it's not the same pattern. The same pattern must work for all of them. So it's not adding. That means it's not taken away. So what other operations do we have? Well, we have times in. So 2 times what is 4? That's 2. Oh, and look, that's times 2, and that's times 2. So we could say the x coordinate is always half, because obviously the opposite of timesing is dividing. So the blue numbers are half of the purpley ones. Or we could say the y's are double the x. So x is half the y's, or the y is double the x. Now, we can always hide a multiplication sign. It's the only sign we can hide. We do that by putting 2 things together. So that's 2 lots of x. So please write it using this notation rather than 2 times x. So that's it for this video, and your teacher will give you loads of these to practice, and then we're going to take it on to some harder ones.